If you talk about science as a process, as a human endeavor, I would say that we have been evolving from an era in which people in the 15 and 1600s began to formalize the scientific process. Say, do it this way, and you'll be able to reason accurately. And we had some very good, very objective scientists. Most of them, by the way, were doing it on their own just because they were reasoners, they were scholars, they just did it on their own. But in the last 100 years, we discovered that using that method, scientific experimentation and reasoning leading to conclusions, was also a powerful marketing tool. So by the time whether something was scientifically validated or not became a reason for why we would pay for it or not, science became, when you said what's the difference between subjective and objective science, you were saying between a case history report of an individual personal situation and some experiment done with
Double
large
blinds,
groups or
right.
double blinds or anything else. That's not what I thought you were talking about at all. Here's what I thought you talked about. Objective science, science is objective science. There's no such thing as subjective science, except I think we have a huge amount of subjective pseudoscience going on the planet today that's being credited with being scientific. For instance, let me tell you, if you actually wanted to do any nutritional science, you would have to gather large groups of people and compare what happens as their diet changes and what the consequences are. And you would never be able to say something like this: a study suggests that, and therefore you should do this. Because science doesn't work that way. But I have heard that many, many things are supported in our society now because a study suggests that, and therefore you should do this. That's what I call subjective science, because most of that science is being done not to actually weigh and evaluate whether that's the way the
Total
world
marketing.
really works, but because the study that suggests that is being paid for by the person who wants the study to suggest that so that they can sell you the product. And unfortunately, a lot of what we call scientific validation in the biological field, which includes nutrition and health care and every product you ever needed, including how to vitamin proteinize your hair, is all subjective science. It's all science, the pseudoscience being done in the name of marketing. The problem with the scientific method is this: the way we reason in science is called statistical analysis. Collecting data is not science. Collecting data is just collecting data. But what we do once we collect data is we try and compare where the the differences between the data we got from the control group, the unaltered group, and the data we got from the altered group. And the two groups have to be similar enough that the only difference between them is the alteration, called the variable. And the thing that most people think of as science is setting up experiments and running experiments, which it isn't at all. Setting up experiments and running experiments only lets you start doing science, because the science is involved in trying to estimate, trying to understand, trying to conclude whether the difference in the outcomes is directly related to the difference in the variables or not. And the mathematics we use to try and judge that can give us some pretty strong impressions about whether the differences are significant or not if we're only using one variable. If we can be sure that our two groups are virtually identical except for one variable. If we have two variables at play, it takes more mathematics, and mathematics that we're not as confident of, which means the reasoning is more difficult to come to a valid conclusion that in two variables, it's the change in this variable that led to the outcome, or the change in that variable that led to the outcome, but there can't be any other variables, because in a three-variable problem, science does not have any tools to come to a valid conclusion
Mathematically.
from data mathematically that represents differences that might be driven by three or more variables. It's called the three-variable problem, and right now, any scientist who knows his stuff will tell you it's just gone soft on you. So what you're talking about is the confidence we have in experimental situations, things we can experience, which are simple enough or linear enough that we can control the difference between the control and the variable group and have only one variable. That's called hard science. Physicists likes to work that way. Chemistry can sort of work that way, but here's the rub. Soft science is trying to use that same method of gathering groups, collecting data, and then comparing the outcomes between control and variable groups when in fact you cannot create a single variable situation. For instance, does smoking cause cancer? If you could get a group of 100 genetically identical people and give them exactly the same diet and house them in exactly the same situations and let them lead exactly the same life, you could possibly come to a scientifically valid conclusion about the causal connection between smoking and cancer, because it would be the only variable. You can't do that because people are not single variable phenomena. They're not two variable phenomena. People are almost virtually infinite variable phenomena. So studying people scientifically is always soft science. In fact, when someone says they're doing an RCCP and that's harder science, so we respect it more, they're just trying to jump on the tails of physics and chemistry, because in fact even an RCCP is soft science. It's soft science because it's biological science and because
relating it to the human being.
Because it involves human beings.
And human beings are very susceptible to open system, a lot of influences. They're not
susceptible. They are open systems, for God's sake. The only way you can close a human being down from being multivariate is kill it. Right. And so that's what you're talking about. And that prejudice comes to us not from the drug companies. The drug companies are just borrowing that prejudice from chemistry, which chemistry is considered a hard science because you can isolate a group of known reagents in a chemically pure environment and they're the only things that are acting. It's not that hard to do because chemistry can be done on a simple level. Your chemistry cannot be done on a simple level because you are a reagent beaker with about 7,000 different types of cells in you, carrying about 38 quadrillion different reactions in you right now as you sit there. And so that's what you're talking about. And that whole prejudice is in play. And so what we've done is we've tricked ourselves. We're deluding ourselves by thinking that we can test drug interactions with the human being and come up with valid conclusions. And the fact that every once in a while the safest drug you know of kills people outright is okay because the level of probability is low enough. Aspirin is considered the safest drug ever discovered. Just give aspirin to anybody over the well, but not babies. And the safest aspirin in the world, aspirin, kills about 115 people a year because they take an aspirin and it's the wrong time in the wrong place for their physiology. They react to the aspirin, they die from it. That's a soft science problem. The human being is complex enough that there's no way you can have any input into that human being and know what the outcome pathway's likely to be, except in the largest, most statistically evident sense. That's what you're talking about. And it's a huge problem. And it's one of the reasons why, in the end, scientific methodology is even more clearly inadequate to be the only methodology you use to understand people. You don't really have to get into philosophic opinions if you want to understand chemical reactions, because they're so simple that the one variable method of science will probably reveal how they work to you.